Hey there, Whitman Wildcats. It's Mr. M here. Thought I'd make a video to help get you going with problem number 22. It's from our homework assignment 3G number 3. You can find this in our green books. It's on page 13. And problem 22 says that many single-celled organisms reproduce by dividing into two identical cells. Suppose an amoeba splits into two amoebas every half hour. And I thought I'd just throw in a biology term here real quick. This process of splitting into two is actually called binary fission. And that's just a fun biology fact. Maybe you'll encounter that in science class. So part A asks us that an experiment starts with one amoeba. Make a table showing the number of amoebas at the end of each hour over an 8-hour period. And I want to point out that the table says we want each hour over the 8-hour period, but amoebas, they don't split on the hour. They actually split every half an hour. So that's something we have to watch out for. And rather than go straight to the table, I thought I would make a quick illustration to show you exactly what's going on. So at time equals 0, we have one amoeba that we start out with. And it's not the most scientific drawing, but it'll do. So half an hour goes by, and our one amoeba splits into two. And another half an hour goes by, and those amoeba split into two. And when another half an hour goes by, each of those amoeba split into two. And when another half an hour goes by, you can see what's happening here. It's take me a second to draw them all out for you. But hopefully you can tell that we're getting a lot of amoeba on this page pretty quickly because they're growing exponentially. So rather than continue drawing them, let's go ahead and see if we can get a pattern going. Well, at time equals 0, we have one amoeba. And after half an hour, our first amoeba splits, and it becomes 2. And now when another half an hour goes by, time equals 1 hour, our 2 amoeba split again and become 4. And when another half, after an hour and a half has passed, those 4 amoeba split again and become 8. And they split again at the 2-hour mark and become 16. And they split again at 2.5 hours and become 32, and split again and become 64. And when we look back at the problem, that we're only interested in each hour, not the half-hour marks. So after half an hour when we have 2 amoeba, not interested in that info. After an hour and a half, not going to be part of our table. After 2.5 hours, again, not part of our table. So let's make this table already. Over here, T, time, that's our number of hours. On the right, A, the number of amoebas. At time equals 0, we have ourselves one amoeba. And after 1 hour, our amoeba has become 1 hour. We'll jump all the way up to 4. So 1 hour's gone by, and we've got 4 amoeba. And after 2 hours have gone by, we're actually up to 16. And when 3 hours have gone by, we're all the way up to 64 amoeba. And so now to finish out our table, 4, 5, 6, 7, and 8, we're going to do 64 times 4, and that's actually 256. And 256 times 4 becomes 1,024 amoeba. And we continue multiplying by 4. And we get 4,096. And we multiply by 4. And we get 16,384. And we multiply by 4. And after 8 hours, the total number of amoeba is 65,536. And before we continue on to part B, what I want to show you is that 16, everyone in my class knows, is 4 squared, 4 to the second power. And if we continue multiplying by 4, as we go from 16, we multiply by 4 to get to 64. This is sort of like saying 4 times 4 squared, and that's really equal to 4 to the third. And now 64 times 4 is 256. Well, that's like saying 4 to the third times 4, which actually gets us 4 to the fourth. And 1,024, well, that's going to be 4 to the fifth. And 496, 4 to the sixth power. And 4 to the seventh. And finally, 4 to the eighth power is 65,536. Well, let's work backwards here. In case we didn't know, 4 to the first power, well, that's just equal to 4. And so, sort of working backwards, what about this 1 up here? Well, 1 is actually, I'll write it over here. 1 is actually 4 to the 0 power. And you can see as we work, if we go from 4, 3, 2, 1, working backwards, 1 is really 4 to the 0 power. That's something we haven't talked too much about yet in class. Maybe you already know that one, maybe not. But here's sort of an interesting one to file away. So anyhow, here's our table. We've got our values for time equals 1 up to time equals 8, and we have our total number of amoeba. So if we flip back to our problem, part A, we got that checked off. Part B now asks us, it says, write an equation for the number of amoebas A after T hours have gone by. And so as we look, as our time went up, our number of amoebas increases. So the number of amoebas, that depends on how much time has passed. So the amoebas A is our dependent variable, and our independent variable is T, T being the number of hours that have gone by. Well, we've got this nice pattern going on over here. So we can see that when 2 hours have gone by, we have 16 amoeba, which is 4 squared. And so we've got this 2 as the exponent. So 2 on our independent variable, and sure enough it shows up over here as 4 squared. And after 5 hours have gone by, again, the exponent, we have 4 to the 5th power. So let's write our equation. Again, the number of amoebas A depends on the number of the amount of time that's gone by, T. So A depends on what our T is. And when we look back at the table, we've got 4 to some power, 4 to some power. So we know it's going to be 4 to some power up here. We don't know what it is. Well, all you do is take the independent variable T, and you put it right in as the exponent of 4. So we can actually say 4 to the T power is what's equal to A. So now we've got our equation. I will leave the remaining parts up to you, but you've got A and B done, and we shouldn't have too much of a problem going ahead with C, where we can figure out how many hours is it going to take to reach 1 million amoebas. and graphing and all that good stuff. Shouldn't be too bad for my class. So I hope that helps get you going and clear some of that stuff up. And lastly, just a quick plug that I would really like to get more students helping make these videos. And let me know if you found this one to be help get you through. All right, we'll see you in class. Bye-bye.